Okay, students, once again, I welcome to this wonderful topic today. It's about values of Boolean expression. Values of Boolean expression. Okay, so any Boolean expression of the form which contain only 0 or 1 is called Boolean values. So Boolean values is nothing but it is a Boolean expression which should contain 0 or 1. Okay, it should not contain any other English letters or whatever it may be. It should contain only 0 and 1. Then that Boolean expression have the Boolean values. Okay, so any Boolean expression of the form which contains 0 or 1 is called the Boolean values. Okay, now let us take this is what already we have discussed this in an WhatsApp I sent to you. How many of you went through? I don't know. So this is one expression, this is another expression. Am I right? This is transformed into like this. Now look at that. This is transformed like this. 0 and 1. Am I right? So these are the values we are giving to this particular Boolean variables. So these are called Boolean values. Boolean values for this variable A0011. For Boolean values of B, chances are 0110. When the A takes these values, A dash takes all the values. That's what you have to understand. Now coming to gates. What is the gate of gates of what is a gate? Now look at this. This is a gate like, am I right? Or this is gate like. This also gate like. This also gate like. So here also we have gate like that. On the basis of the picture like that, we have the problems here. So what is then logic gates? So logic gates are nothing but a network picture like this, or like this, or like this, or like this, which evaluates any Boolean expression is called Boolean gates. So Boolean gates are nothing but a network picture, network which determines the values of the given Boolean expression. Those network picture we call it as circuits or gates, we say. So gating networks is nothing but circuits which have no memory capacities is called gating network. So gating network again is nothing but a network which determines the Boolean expression. Now look at that basic type of networks. First one is inverted gate. What is that? Inverted gate is nothing but, look at that, the variable Boolean expression is coming inside, and when it go out, it complement comes. Am I correct? It is coming inside, it is converted into its complement. Okay, and this is called a converted gate because this gate converts this x into x dash or x into x complement. Therefore this gate is called inverted gate. So an inverter accepts the value of one Boolean expression x and as an input and produces the complement of this as its output. So input is what? The Boolean expression. Output is what? Yeah, complement of this Boolean expression. This converter we call it as invert gate because it inverts. Another one is called OR gate. What is the OR gate? Suppose there are one or more Boolean variables are coming as an input and the output is the sum of their inputs. The output is sum of their input, then it is called OR gate. Sum, or otherwise we say join, or otherwise we say plus, round plus, like that. Okay, so look at the picture here. There are two there are two Boolean variables are coming in. What this gate does, it joins, or it sum up, or it adds one and the other. Such a gate network, or the converter, we call it as OR gate. We say OR gate. Now next one, we talk about the AND gate. AND gate is nothing but one or more Boolean variables are coming in. The output is the product, or the multiplication, or AND of these two variable. Then this particular gate, we call it as AND gate. So AND gate is nothing but it makes AND connective between the incoming variables, and the outgoing variable is the AND of all incoming variables, or the product of all incoming variables. Now AND and OR gate for with n inputs. Here you are seeing only two inputs, and coming is consists of only two variables. Okay. Now here the input is two variables, output is only one variable, consists of join. But here so many variables are coming, n variables are coming, and the output would be the join of this n incoming Boolean variable. Okay, such a converter, we call it as OR gate with n inputs. On some cases it may be like this. The how we say that, AND gate with n inputs, AND gate with n inputs, and it consists of a single output. This gate we call it as what gate? OR gate. Okay, sorry, AND gate. So many gates are there, definitions also is there. Just a recap, gate is nothing but nothing but a network which determines or makes a Boolean expression. Okay, so gating network is like this. So many gating networks. Inverted gate, which inverts the given variable into its complement. Next one is OR gate, when two or more variables are coming in, then the join of all the variable, this converts these variables into join of all the variables. This is called OR gate. And then AND gate, it is nothing but all the incoming variables are converted into its products, or product we say are AND of all these variable. That is called AND operation, or AND gate. And in the gate also we have OR gate with n inputs, as we see here is coming in the sum of all. So OR gate with n inputs, and here all these variables are converted into the product of all the variables, and this gate we call it as AND gate with n inputs. Okay, so these are some of the types of gates in the logical theory. In another class we will take the problem and find out its gate, what would be the final output if the input is like that. Okay, so with that we come to the end of this class. The next class we will be looking at another problem. Thank you, my dear students. Thank you.